So good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chevrolet Engineering College. Today we are going to discuss about some more examples in the inverse Fourier transformation and the Fourier transformation in different types of the examples. Yesterday, day before yesterday also, we discussed about the different types of Fourier transform and inverse Fourier transform examples. So mostly the graphical representation given the signal in terms of graphical representation. You have to find out the signal mathematical expression, and then you can find out the Fourier transform or the inverse Fourier transformation of the given signal. Okay. So as in the last class, we already seen the determine the Fourier transform of the gate function. Determine the Fourier transform of the gate function from minus t by to the t by 2 with an amplitude of a. The x of t is equal to and 0 the remaining functions t by 2 the infinite and minus infinite to the minus t by 2 and t by 2 to the infinite all the values is a 0. Okay, and by using the Fourier transform definition, the x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. But x of t from minus t by to the t by 2, the value is a. So taking the limitations is minus t by to the t by 2 a into e power minus j omega t dt. Apply the integral e power minus j omega t. You get the e power minus j omega t by minus j omega, upper limit t by 2 and lower limit minus t by 2. After simplifying, we get at by omega t by 2 sine omega t by 2. And convert this into the sinc function, x of f is equal to at into sinc f of t. Okay, my dear students. We already seen the last class it is. Coming to the next one. Now it is a very important, the given function. Find the Fourier transform of the following waveform. Find the Fourier transform of the following waveform. There is 3 stages are there. One stage is from minus b to minus a, and another stage is minus a to a, and the last stage is a to b. The 3 stages have to find out the given graphical representation to the signal x of t is equal to. Then after you can find out the x of j omega or x of omega, nothing but the Fourier transformation. Okay, my dear students. Now, first of all, if I am taking the minus b to the a, you see how it looks like minus b to the a, minus b, and here it is a minus a, is a slope, is a 1. Okay, my dear students. Now, the minus b is in the x-axis, nothing but the t variable, and the y of, not the y of t, it is x of t signal, given x of t signal. So minus b is the x-axis, so minus b and the 0 is x1, y1, and minus a is also in the x-axis, so minus b and the 0. A point on the x-axis means y is a 0. A point on the y-axis means x is a 0, my dear students. Let these 2 points is on the x-axis, x2, y2. So I'm using these 2 quadrants, and you have to find out the slope of this in between of minus b to the minus e. What is the equation? Y minus y1 is equal to y2 minus y1 by x2 minus x1 whole multiply with x minus x1. Okay, my dear students, this is the equation we know, line equation. What is the y here? Y is x of t signal. X of t minus, what is the y1? See, y1 is a 0 here. 0 is equal to, what is the y2? 0 minus y1 is a 0. y2 minus y1 is not the b, a, my dear students here. The quadrants what we have here, it is somewhat wrong. See, x is a means the point is in the y-axis 1, my dear students, minus a and 1, not the 0. At a there is a 1. Okay, now it is y2 is a 1, 1 minus 0 by, and x2, what is the x2 here? Minus a, and x1 minus of minus b into whole multiply x. What is the x here, my dear students? It is in the x-axis the t variables. So t minus x1 minus b. Okay, my dear students. So a little bit we did a wrong. Here it is not the minus a 0, minus a. At minus a, what is the value of y? 1. At minus b, what is the value of y? 0. Because it is in the point on the x-axis. But here it is not the point on the x-axis. At minus a, the t value, the y, nothing but x of t is a 1. Okay. X of t minus 0 means x of t is equal to, this here 1 minus 0 is a 1, minus a minus into minus b. So I will write it as b minus a, and t minus of minus b is t plus b. T plus b. See here, x of t, we got the t plus b by b minus a. T plus b by b minus a in the range of minus b to the minus a. And the second range up to the plus a, the magnitude is a 1 only. See, the x of t is equal to 1 from for minus a less than t less than a. Now another line equation is there here. Is at the b. Now what is the quadrants here? Now let's assume here x1, y1. What is the x1, y1? X1 is a and y1 is a 1. And x2 is b and y2 is a 0. Okay. Now you can find out by using these two quadrants, the line equation. The same. Use this formula y minus, what is the y here? X of t minus y1 is a 1, y1 is a 1 is equal to, and y2 0 minus y1 by x2 b minus x1 a and x is t minus x1 is a b. So you actually have to take here from the slope, starts from here itself, it is a x1, y1 and x2, y2, my dear students. Actually, it is wrong, we'll get otherwise. Okay, let us see. Okay, change this as x2, y2 and this one is a x1, y1. Okay, now the x of t minus y minus y1, what is the y1 here? The 0 is equal to, and y2 minus y1, y2 is a 1, y1 is a 0, and x2 minus x1, a minus b into x t minus x1 is a b. Okay, my dear students. Now the x of t is equal to is 1 by a minus b whole multiply with t minus b. So now you can observe here the t minus b by a minus b, the third one. Like that we got the slope of from minus b to a is t plus b by b minus a, and here the slope is there is a t minus b by a minus b, and in between from a minus a to a the value is a 1. Using this x of t, you can find out the Fourier transformation. Okay, what is the Fourier transformation? X of omega is equal to integral minus infinite to infinite x of t into e power minus j omega t dt. Okay, what is the x of t in the range? First of all, I am taking the range as minus b to minus a, minus b to the minus a, x of t, t plus b by b minus a into e power minus j omega t dt. Okay, my dear students. Plus and integral minus a to plus a 1 e power minus j omega t. Okay, plus a to b t minus b by a minus b e power minus j omega t dt. So total is 3 integrals, the range of x of t from minus b to minus a and minus a to a and a to b. That is equal to, see here the minus t plus b by b minus a is a constant. For this integral e power minus j omega t whole divided by minus j omega with limitations minus a to minus b plus, and here also e power minus j omega t by minus j omega with limitations a to minus a plus, and here the t minus b by a minus b and e power minus j omega t by minus j omega with b to a. Now apply the upper limit and the lower limit in the e power j omega t is equal to, so carefully you have to simplify this equation, otherwise you'll get the wrong. T plus b by b minus a and upper limit e power minus already here by substituting the t as a, j omega a, okay my dear students, minus e power, already here also the minus is there, now we'll get the minus into minus is a plus, j omega b, okay, divide by minus j omega plus, and here also e power upper limit is a plus, so minus j omega a e power plus j omega a by j omega. Okay, my dear students, plus t minus b by a minus b, and here also the e power minus j omega b minus e power minus j omega a whole divided by minus j omega. Okay, my dear students, here the minus j omega is there. Still you go for the simplification. I will take it is the whiteboard, my dear students. We got t plus b minus a e power j omega a e power j omega b by minus j omega and e power minus j omega e power plus j omega by minus j omega and e power minus j omega b e power minus j omega by minus j omega. And in the last term it is multiplied with the t minus b by a minus b. Okay. Now you take this. Further you go for the simplification. For that we got the t plus b by b minus a multiplied with both are it is a positive e power j omega a minus e power j omega b by minus j omega and plus e power minus j omega a minus e power j omega a whole divided by minus j omega plus, I think it is a t minus b by a minus b e power minus j omega b minus e power minus j omega a whole divided by minus j omega. Okay. And take the minus 1 by j omega is common for all the terms. And t into b minus a e power j omega a minus t by b minus a e power j omega b plus b into b by b minus a e power j omega a minus b by b minus a e power j omega b. Okay, my dear students, these are the four terms we'll get for the first one. And plus e power minus j omega a minus e power j omega a plus, first of all I am taking the t by a minus b e power minus j omega b minus t by a minus b e power minus j omega a and minus b by a minus b e power minus j omega b and plus, because here the minus is there, it's the minus, plus b by a minus b e power minus j omega a. This is after multiplication. See any common, the t b by minus a and t a minus b. And t b minus a e power b here and e power b. You see the first two terms and here the two terms, minus 1 by j omega. Take the t by b minus a and t a minus b. Both the terms you can take it as a values only, my dear students. I'm taking here is the first one and this is the second one. Take b minus a is a common. Now it becomes plus t by b minus a. Then it becomes of e power j omega a. It is now it is a plus e power minus j omega a. Okay, my dear students. Then you take these two terms plus t by b minus a, you can take as a common b minus a and take the minus here, then you get both are minus e power j omega b, and here take the b minus a is a common, here the you get the minus e power minus j omega a, j omega b. Okay, my dear students. Now we got by using these four terms, then another two terms here, it is b by b minus a and b by a minus b here. B by B minus C and B by A minus B e power minus. I am taking the now it is a B by B minus A e power j omega A. Now the B minus A means minus e power minus j omega A. Following. Then after these two plus, not the plus, take the minus directly, minus these two, my dear students, B terms. B by B minus A, you take the common, e power j omega B here. B minus A means it becomes of plus. Okay. B minus A, it is a plus. We already taken it is a e power minus j omega B. Okay, my dear friends. B by A minus B minus it is okay. And here minus already there, minus T by B minus A e power j omega B and T by A minus B B minus A. So the minus is there. We already take the minus is a common means it's a plus A minus B. Okay. Then the remaining two terms we have, it is plus e power minus j omega A minus e power j omega E. Okay, my dear students. Now, in these two, the first two terms, T by B minus A is a common. In this second term, B by B minus A is taken as a common. Okay, my dear students. But here, what is the value of e power j omega plus e power minus j omega by 2? And for this one, B by B minus A power j omega, and it is a minus B by j omega. Okay. It becomes of e power, it is a cos function, and this one is a cos function, and this one is a sine function, and this is a cos function, my dear students. And this is a sine function. Convert all these terms into the cosine functions and the sine functions. Cosine functions and the sine functions. And finally, we'll get in terms of this here, cos omega A minus cos omega B. See, there is no any sign. So if something will went wrong, is a cos, and here also cos, here also cos. And So we did a wrong mistake, wrong, my dear students. See, so in this, we are applying for the t with respect to the t is also there here. I am taking this as t plus b by b minus a is a constant, and here the t minus b by a minus b, I am taking the constant. What we did is this total, it is a wrong, my dear students. But again, see, the x of omega is equal to minus infinite to infinite x of t e power minus j omega t dt. What is the x of t here? Minus b2 minus a t minus b by b minus a into e power minus j omega t dt. Okay, my dear students, plus integral minus a to a 1 into e power minus j omega t dt, and plus integral a to b t minus, this is a t plus, my dear students, a t minus a minus b by t minus b by a minus b e power minus j omega t dt. Where we did wrong, my dear students, it is a t is there here. I taken it is a totally the t plus b by b minus a is a constant. Only b by b minus a is only the constant. Okay. Now these two integrals will get as t by b minus a e power minus j omega t. This integral minus b2 minus a plus b by b minus a as a constant, integral minus b to a e power minus j omega. Okay, because if the t is there here, t into e power minus j omega t, that will get a ramp function, t into e power minus j omega t for the ramp, plus, and here integral minus a to a e power minus j omega t dt. Here the dt is there every time, don't forget that one, dt, plus here also the integral a to b t by a minus b e power minus j omega t dt plus integral a to b minus b by a minus b e power minus j omega t dt. Alright, my dear students. That is equal to, now it is a t into e power minus a t, 1 by b minus a, only the common term here. Okay, the integral with the t into e power minus j omega t, you can apply here the by parts, integration by parts. And for this, there is no any integration by parts, directly you can substitute this one. So integral minus b to a minus b to minus a t into e power minus j omega t dt. Here you can apply the UV rule, plus b by b minus a into, directly I am substituting here, e power minus j omega a minus e power j omega b whole divided by minus j omega. Okay, my dear students, plus here also I am directly substituting here, e power minus j omega a minus e power plus j omega a whole divided by minus j omega. Is a one function. Here also the by parts, t into e power minus j omega t dt with the limits of a to b. Here the minus is there. Minus, take it is a total, it is a minus value, you'll get here, it is a minus. Change of the limitations here. Change of the limitations and keep the minus. So both are the same. And here is the minus and here the minus. Okay, then plus, otherwise you can keep directly like this, 1 by a minus b, a to b, t into e power minus j omega t dt. For this a to b is a limitation, my dear students. A minus b, the minus b, the total is a constant, e power minus j omega t dt. A to b, the last term integral a to b minus b by a minus b minus b by a minus b e power minus j omega t dt. For this, we'll get minus b by a minus b e power minus j omega b minus e power minus j omega a whole divided by minus j omega. Okay. Now I can see any common terms is there. B by b minus a, and here b by a minus b. So now it is also changed that minus b by the same thing as a b minus a. B minus a, b minus a means it is a plus. Okay, my dear students. E power minus j omega b minus e power minus j omega a whole divided by minus j omega. What is here? E power minus j omega a plus, and here the minus e power j omega b, e power j omega b. It is also the minus, I think, students. It is a minus. Okay. In these two terms, b by b minus a, e power minus j omega b, and here also e power minus j omega b, but it is a minus here. Here the plus e power minus j omega a, and here minus e power minus j omega a. So these totally get cancelled off b to a and this one. Okay, my dear students. And the remaining function, and the remaining functions, we have only 1 by b minus a with a t to e power minus j omega t, and 1 by a minus b t into e power minus t dt. To simplify this by using the by parts, and the remaining function e power minus j omega a minus e power minus j omega a by minus j omega. Here it is a e power minus j omega a and minus e power j omega plus a, e power j omega plus a minus e power j omega a whole divided by j omega minus j omega minus. Okay, we take the minus as a common, it becomes of e power j omega a minus e power minus j omega A whole divided by j omega. Okay, my dear students, it is in the form of e power j omega is a minus here. I'm taking the minus into minus here, and minus e power minus j omega by j omega. One thing. Then you can simplify these two terms, b minus here, and here also to take the b minus is a common. Then finally we get this equation, b minus a is a term, and j omega into j omega minus the denominator we have j omega into j omega minus. So after applying here, it is a j minus j omega will get, and here also for this one minus j omega is a j omega and j omega whole square. So j square is a minus 1, and minus into minus is a plus. It becomes of omega square only. In the denominator we'll get in the denominator, so omega square into b minus e, because it is a j omega whole square minus 2. Then convert this exponential values, whatever you have, we will get after the applying the by parts. And these two terms will get cancelled. After applying here the by parts and here the by parts, whatever the term we have here, e power j omega a and e power minus j omega a get cancelled. Then after one value we have with the minus b here, the plus b, and minus a and the minus a, that is a cos a and the cos omega and cos omega b. Cos omega a minus cos omega b will get. Okay, a little bit simplification is there. You have to do that one, my dear students, by applying the by parts there. Then next one, determine the Fourier transform of the signal x of t is equal to t mu of t with the convolution here. See, convolution mu of t minus mu of t minus 1. So the two time domain signals is convoluted. What is a frequency domain signal? We know according to the convolution property, convolution time domain property of the Fourier transformation, time is convolute means frequency is a productor. Frequency is a productor. So I'm taking this one is x1 of t. Let us see here the x of t is the two terms. x1 of t is a t into mu of t, and x2 of t is a mu of t minus mu t minus 1. Mu of t minus mu into t minus 1 is x2 of t. So t into mu of t. Mu of t is a j omega actually, and it is a t is multiplied means 1 by j omega whole square. 1 by j omega whole square. Anything it is multiplied with the t, that will get as square of the function. Following my students. So x1 of j omega is equal to 1 by j omega whole square. And coming to the second one, mu of t minus mu of t minus 1. So first of all, you can simplify this equation. To simplify this equation, what is a mu of t? So mu of t is varies from 0 to infinite as a t variables, and mu of t minus 1. Mu of t minus 1 means one sample is shifted towards the right side from 0 to 1. Now you can subtract these two functions. Subtracting of these two functions, so mu of t minus mu of t minus 1 is a 0 here, and 1 minus 0 is a 1 up to the 0 to 1, and from 1 to infinite both are 1s. So a value is a 0. We have only the magnitude is 1. Magnitude is 1 between the 0 to 1. The 0 to 1. So for the x2 of t, the Fourier transformation is integral 0 to 1. The value x of t is a 1 e power minus j omega t. So apply the integral for e power minus j omega t as e power j omega t by j omega minus, okay, e power minus j omega t whole divided by minus j omega. Upper limit is 1 and the lower limit is 0. When substituting the upper limit, it becomes of e power minus j omega into 1 minus e power 0 is a 1 by minus j omega. Now it becomes a minus, you can take as a common 1 minus e power minus j omega by j omega. Okay. Now you can multiply the two functions. What we got is the x1 of m, x1 of omega and x2 of omega, 1 by j omega whole square. Now the denominator is a j omega whole cube into 1 minus e power minus j omega. So using convolution property. The given two functions, two time domain functions are convolution and frequency domain functions are the product. Individually, you can take x1 of t is a t into mu of t and x2 of t is equal to mu of t minus mu of t minus 1. Apply for t into mu of t the Fourier transformation 1 by j omega whole square. And for the Fourier transformation of a second signal 1 by j omega into 1 minus e power minus j omega. The product of two functions x of j omega is equal to x1 of j omega and x2 of j omega 1 by j omega whole cube into 1 minus e power minus j omega. Okay. The previous example a little bit complicated. Okay, my students, you can simplify. You'll get the answer. Don't worry for that one. And coming to the next example, find the Fourier transform of the signal x of t. Here also, first of all, you can find out the slope equation and then from 0 to t and t to 2t, the value is a. And 0 to t, here the C, 0 to t, how we got the a by capital T into t for this. Here the 0, 0 and the t into a. 0, 0 and the t into a. So both are in the y-axis. The t at the t, the value is a and x is x0 and y0. So x1, y1. Now we'll explain here. And let it is a x1, y1 and this is a x2, y2. So y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Y is x of t minus 0 is equal to y2 is a, y1 is a 0, x2 is a t, and y by x1 is a 0, and x value is a t minus x1 is a 0. So x of t is equal to a cap by the capital T into small t. That we got the slope equation. X of t is equal to a by t into t in the range of 0 to t minus 2. And from t to 2t, a is a magnitude. So using these two ranges, we apply the Fourier transformation of this signal. A by t, the integral 0 to t, t into e power minus j omega t into e power minus j omega t, and plus a into the magnitude, the range is t to 2t, e power minus j omega t d. Okay, now here see the integration by parts you can apply. the first of all, you can take the t, apply the integral of this one, e power minus j omega t by minus j omega, minus, and the derivative of t is 1, and apply the integral of this one, e power minus j omega t by minus j omega, here all the minus we can get, okay, into dt, plus for the second term, a into e power minus j omega t by minus j omega with limitations of 2t and the t. Again, you can see here the t into the t e power j omega t minus j omega plus, again you can apply for this the time the integral matter students, e power minus j omega t by j omega, and j omega will having the j square omega square, and that j square is a minus and becomes is a plus. After substituting the upper limit e power minus j omega t and lower limit is e power minus 0 is a 1. Okay, my dear students. Then here also a into e power minus j omega t, upper limit is a 2t and a lower limit is a t minus 0. Alright. And then you can simplify this expression a into e power, because tt get cancelled here, my students, a into e power minus j omega t by minus j omega. It is not the minus, my students. Here the minus is there. Here is a minus is there. Okay, there is a missing term. E power minus j omega t by minus j omega, and this factor is multiplied with the t, 1 by omega squared into t, e power minus j omega t minus 1, and a by minus j omega, e power minus j omega t, it takes as a common, and here 1 e power j omega t is outside, another 1 e power minus j omega t minus 1. Okay, my dear students. So now the first term is a into e power minus j omega t by j omega. Here it is a t is there. Since we can apply the, here also the term is not the small t, capital T minus 1. Here also not the capital small t, it is a capital T only. Since the upper limit is a t. So for this t, you can substitute the capital T e power minus j omega capital T. For lower limit is a t is a 0, there is no any second term here, only the first term. T into e power minus j omega into capital T by minus j omega, and here also e power minus j omega t minus j omega. Why this t and this t get cancelled? So a into e power minus j omega t by j omega. J omega is a minus, my dear students. Minus is there. Okay. And this a is multiplied here, a by omega square into t, e power minus j omega t minus a by omega square into t. Okay. Minus a by j omega into e power minus j omega t, or you can take the e power minus j omega t and e power j omega t minus 1 is a common, you'll get these two terms. Plus a by j omega into e power minus j omega t. Simplify this again. A by omega t, because 1 will get cancelled. A by j omega, and here also the a by j omega is there. It is e power minus j omega t, and here the e power minus j 2 omega t. And a by omega square into t e power minus j omega t is the first term we'll get here. A by omega square into t e power minus j omega t, and a minus omega minus 1 by j omega into a by omega square into t square. This is a term, my students. Second term. So for this function is the first one, a by omega square into t e power minus j omega t, and this a by omega square into t. These two terms are considered. And next here, a t e power minus j omega t, e power minus j omega minus 2j omega t. Why 2j omega t? A is there, and now the omega t. Okay, this is a third term. A by j omega, and this is a plus. Why it is a plus means now you can take the j as in the numerator. Numerator it is becomes a plus j e power minus j omega minus 2j omega t, and here the outside there is a value is common term, and the omega is already there, and here taking the t, multiply here the t. Okay, three terms. These three terms we got, and a by minus and a by plus, these two are get cancelled. Okay, my dear students. Now we got it. What is the final answer? A by omega t is equal to 1 by omega into e power minus j omega t minus 1 by omega minus 1 by omega plus j into, why you got this plus, my dear students? The j is in the denominator, it is a minus. I wrote here the j is in the numerator. So minus j will get here, and minus into minus is a plus. Why you got the t here? Already there is a denominator, the t is there, and these two get cancelled, becomes of a by omega into e power minus. And the last term and the first term is both are the same. A by minus j omega it is, and a by plus j omega. These two are get cancelled. Only we have these three terms by taking the common of a by omega into t. Got it, my dear students? Okay. And then coming to the next one. For the differential equation, if any differential equation given, how we can find out the Fourier transformation for the linear time invariant, linear time, continuous linear time invariant system. So suppose here they given the t square y of t by dt square 4 dy of t by dt, dy of t by dt d square y of t by dt square plus 4 into dy of t by dt plus 3y of t is equal to, is a d square y of t by dt square and 4 dy of t by dt plus 3y of t is equal to, and derivative of x of t and x of t. We know the time differentiation property. Time differentiation property saying that d by dt of x of t, the Fourier transformation is, what is the Fourier transformation? J omega into x of omega, and d square y by the dt square x of t, the second derivative. What is the Fourier transformation? J omega whole square into x of omega. Remember this one. The first of all, it is a d square by dt square y of t. So since here the x of t, here we will get the x of omega. So j omega whole square y of j omega. And second term, see here the 4 into, it's the first derivative one. First derivative means j omega into y of omega. Why it is a y of omega? The signal is y of t. And third term, you can see the 3 into y of omega. See the x of t, the Fourier transformation. What is the x of t Fourier transformation is? X of omega. Okay, what is true? And here the derivative is there. First derivative, j omega into x of omega, and x of t is x of j. Take all the terms in the here, the y of omega is there, j omega whole square, 4j omega, and 3. And here also take the x of omega as a common, j omega plus 2. So these are one of the formula is there, according to the convolution property, saying that y of t is equal to x of t, the convolution of h of t, that is, okay. Apply the Fourier transformation on both sides. What is the Fourier transformation of y of t? Y of omega. And what is the Fourier transformation of convolution of time domain signal product? X of omega into h of omega. Okay, my dear students. Now only we did on the convolution by using the convolution property. There is a two products, frequency domain. Now the h of omega is equal to, what is the h of omega is equal to y of omega by the x of omega. Is the equation. H of j omega is equal to y of j omega by x of omega. Take the y of by the x of by x of is 2 plus j omega by j omega whole square plus 4j omega plus 3. Okay, my dear students. Got it? So in the denominator there is a quadratic expression, a square ax square plus bx plus bc. You can find the roots by using the formula minus b plus r minus square root of b square minus 4ac by 2a. Otherwise, you can directly by using our calculator also can find out the factors. Using these factors, h of omega is equal to a by 3 plus j omega and b by 1 plus j omega. Following, my dear students, is a Fourier transformation. And this Fourier transformation, you can find out the inverse Fourier transformation. Inverse Fourier transformation. How you can find the inverse Fourier transformation? By using the partial fraction method. We got the h of j omega is equal to, so a into 1 plus j omega plus b into 3 plus j omega is equal to, what is equal to here, the 2 plus j omega. Here I find the factors of the denominator and take it as by using the partial fraction method, a by 3 plus j omega and b by 1 plus j omega, and can find out the a and the b values. First of all, you can see the constants you can compare. 2 is equal to a plus 3b. A plus 3b. Compare the coefficients of j omega. 1 is equal to a plus b. A plus b. So subtracting these two, a get cancelled. 1 is equal to 2b. So b is equal to 1 by 2 minus. B is equal to 1 by 2. What is the a now? A is equal to, b is equal to 1 minus a. Nothing but a is equal to 1 minus b. 1 minus b is again, it is also 1 by 2. So now this function you can rewrite as a is 1 by 2 by 3 plus j omega plus b is also 1 by 2, 1 plus j omega. Now whether you can write or wrong, it's a 1 by 2 plus 1 by 2 j omega, 1 by 2 into 3. So 1 by 2 plus 3 by 2. What is a 1 by 2 plus 3 by 2? 1 by 2 plus 3 by 2 is a 4 by 2 and the 2 is a constant. And 1 by 2 j omega and 1 by 2 j omega, it is a j omega. Okay, whatever the values we got is right. Now apply the inverse Fourier transformation. What is the inverse Fourier transformation of h? H of t is equal to 1 by 2 is a constant, my dear students, and 1 by a plus j omega. 1 by a plus j omega is equal to e power minus 3t mu of t. Because what is the a here? 3. And for the second term, 1 by 2, it is also in the form of 1 by a plus j omega, but a is 1. So e power minus t mu of t. So finally, therefore, the inverse Fourier transformation, the h of t. See the impulse response h of t. You have to find out, determine the frequency response h of omega and impulse response h of t. H of t is equal to, take the common of 1 by 2. The term is first term minus 3t plus e power minus t mu of t. This is the inverse Fourier transformation of h of j omega. This we can call it as a frequency response, because in the frequency j omega, and this is impulse response. Actually, it is not the impulse response, my dear students. Impulse means delta. You can call it as a unit impulse. H of t is also the one of the unit impulse. How for any system, suppose here the system is there, you can apply the delta of t, the response is h of t. For any system, the input is a delta of t, the response is, the input signal is a delta of t, impulse signal. The response after the system performs the operation on the signal given the impulse, will get unit impulse response. Unit impulse response, we are calling it as this also the response h of t, the output signal. Understood? Here we combine the Fourier transformation and also the inverse Fourier transformation by using time differentiation property, my dear students. If it is a third derivative, j omega whole cube, simply j omega whole cube. Understood? And the last one here is the last example. Determine the Fourier transformation of the signal. The signal is given 1 by 2 delta of t plus 1, delta of t minus 1, delta of t plus 1 by 2, and delta of, my dear students. Here the plus is there here and delta of. Something went wrong here. Don't worry for that. Here it is a plus and this is a into delta of t minus 2. Okay. Delta of t plus 1 means advanced signal. This is a delay of one sample of the impulse signal, advanced of 1 by 2 signal, and delay of a 1 by 2 signal. Take the Fourier transformation definition, substitute here the whatever the given signal is there, e power minus j omega t dt, and split that is all the 1, 2, 3, 4 parts, the integral delta of t plus 1, delta of t minus 1, delta of t plus 2, and delta of t minus 2. We know the Fourier transformation of delta is a 1. And whenever if it is a shifted is there, it is multiplied with the e power plus or minus, depends upon the value here. If it is a plus, we'll get e power minus, and it is a minus e power plus. Okay, plus or minus using shifting property. What we can say, the e power t minus t naught. What is the Fourier transformation? E power minus j omega into t naught x of omega. Okay, so delta t plus 1, 1 by 2 you can take it a common, t plus 1 e power minus j omega, and t minus 1 e power plus j omega, and plus t plus 1 by 2 e power j omega into 1 by 2 and e power minus j omega. One time it is a plus and one time is a minus. X of t plus t naught is a Fourier transformation, e power j omega t naught into x of omega. And simplify this, e power j omega plus e power minus j omega by 2, and e power plus j omega 2 minus e power minus j omega by 2. It is a cos omega, and this function is cos omega by 2. So x of omega is equal to cos omega plus cos omega by 2. Okay, my dear students. So it is a completion of all the examples of inverse Fourier transformation and the Fourier transformation today. So only there is some complicated we got for this function. You can try it try this one. Otherwise, later I will explain for this how we got this 2 pi omega square b minus a and cos omega a minus cos omega b. It's a little bit complicated we got now today. Okay, otherwise you can try it. If you get okay, if you are not at get, I will explain later. Don't worry for that one. So these are the different types of examples we see for any signal. You have to find out the Fourier transform or inverse Fourier transform. So only one topic is remaining in the second. The thing about it is a Hilbert transform. It is a very, very simple topic. The tomorrow's class we start that what is a Hilbert transform. We learn in this second unit the Fourier series, Fourier transform, and the last topic we have the remaining is a Hilbert transform. Okay, my dear students. In the tomorrow class we can see the what is a Hilbert transform. So any questions, please rise. Okay, thank you.